Hello, ladies and gentlemen. My name is Hofmann, as already mentioned, and I'm working for the Austrian Energy Agency. And my main working fields in the last years have been energy management, energy audits, and also a lot of energy performance calculations for companies in various industry sectors. And I'm also a certified measurement and verification professional and trainer for the International Measurement and Verification Protocol, the ITMP protocol. And in my presentation today, I will give you a short summary about the methodology of how to select good practice examples within the UMRC project. The first question we need to address is what does this term good practice mean? Because what is usually known is the term best practice. But a crucial aspect of our project was that our information was based on really and actually implemented energy efficiency projects. So I think, as Simone already mentioned, I think this is very important and distinguishes our approach from different approaches available, and also gives a lot of value to the outcomes of the project. So we have been looking for insights in our analysis coming from practical information and not a mere theoretical approach. Another very important, so we said we want to use the term good practice and we give this term a specific definition. The definition of a good practice in our understanding is a technique or methodology that through experience and research has proven to reliably lead to a desired result in a sustainable way. And we were looking for examples of technical, economical, and ecological proven projects in practice. And another very important aspect is that these measures also have to be innovative. So we are not looking for standard measures for so-called low-hanging fruits like a variable speed drive or water pump for a variable rate. Although we have this information within our database and also within our analysis, in our understanding this could never be able to practice because good practice has to be innovative and proven in practice. And all this information also, Simone said it, is available. The findings that we have are available on the project platform. On the contrary, the definition of a best practice, and traditionally the term best practice is reserved for a technique or a process or a methodology that leads to optimal results. And these optimal results, these optimal results for us in comparison to the good practices is something we also looked on. We studied, for example, we looked on the graph documents developed under Article 13 of the AEA. And these graph documents give a lot of recommendations of best available technologies for various industry sectors. And what we did, we tried to find links between these best available technologies and our good practices. And in the best case, an ideal case, a good practice from us is also the best available technology, but it does not necessarily have to be that way. So what kind of information was available in the project? We have a lot of different information sources. Most information was coming from the project partners, and the project partners have been divided into two groups, the so-called enablers and the so-called followers. The enablers have been the mainly responsible project partners, and most of the information we worked with are coming from these companies. And the followers, on the other hand, have also provided information, but also have direct benefits out of the project outcomes. For example, the enablers have been Carbon Trust, providing information for the UK about energy efficiency and renewable energy recommendations made to businesses, but also to public authorities, public bodies. RSE providing information for Italy, mainly based on the national-wide certificate scheme in Italy. Poland, or CAPE, providing information for Poland, also based on the national certificate-wide certificate scheme. And the Austrian Energy Agency providing information for Austria. And we used two different databases for Austria. One is called the KBC database, which is the environmental subsidy scheme for companies in Austria, and the second one is the Klimaaktiv database. And Klimaaktiv is a big initiative in Austria which tries to foster the implementation of very innovative energy efficiency measures in various industry sectors. The followers have been Greece, Bulgaria, Slovenia, Romania, and we also collected information from Sweden and Portugal. The information coming directly from the companies or project partners, and are also gathered by questionnaires actions. So the target groups, we have several questionnaires actions in the project, and the target groups have been companies, directly companies or industry stakeholders. And we received quite a lot of information, but there is very different level of detail. So we said, okay, we do not want to include it in our key analysis, but we want to look on it on a more qualitative way and evaluate this information also. And we have a cooperation with the De-Risking Energy Efficiency Platform, DEEP, which is founded by the Energy Efficiency Financial Institution Group. It's a European funded project and focuses, as a target group, they also have energy experts and stakeholders of industry, but they're focusing on financial side of long-term benefits of financing in energy efficiency measures. And there are some intersections between DEEP and EU Mercy, but DEEP is more looking on the financial side and EU Mercy more on the technical aspect of energy efficiency measures. So in total, overall, we had about 20,000 records to work with. You can see here a split by industry sectors. Most of the information available was for the food and beverage sector, but also for rubber and plastic and metal products. At the beginning of the project, we needed to make some specifications because also in regard to our desired project goals. So we had a lot of, although Immersive was focused more on the energy efficiency aspect in industries, we had a lot of information about renewable energy measures, and we said we want to include the renewable energy message also within our analysis, because although they are not so high, have not so much benefits when it comes to efficiency, they have a lot of environmental benefits. And also in the original data sets, there have been a lot of measures which have a direct link on only building related measures. And one key aspect also for our Immersive project is that we want to look on industry sectors classified under Class C of the NAS2 revision code. And so we said we want to exclude only building related measures like thermal isolation of buildings, heating optimization of buildings, lighting optimization, LED installations, such measures for us not so interesting. We're looking for measures who have a link to a production process or industry process. And because we have so much information available, we had to focus our attention and our work to a set of chosen industry sectors. So we had the internal sector analysis and choose 8 industry sectors, which for us have very energy intensive industry sectors, but also have a high saving potential. And taking all the specification into regard, at the end we have about 3,000 records we can work with. Also most of the information available was for the machinery and food and beverage sector, but also for the chemical sector. So after presenting to you what kind of information we had, now I want to say something about the methodology, how we really choose a good practice efficiency measure. And there have been 3 key steps for that. The basis of our methodology was a quantitative analysis of the efficiency measures. And this was backed up somehow by literature, best available technique research, more or less. So we looked between links, and this also served as a quality insurance mechanism within the project. And the last step of our methodology was the expert engineering evaluation or expert judgment. And I start with the quantitative analysis. So the first step was the assessment of all information available, all measures, against a set of key performance indicators. And those key performance indicators, they tackle a lot of technical, economical, and environmental aspects that have been specifically developed for the project, and they allow comparison and also a ranking of all measures in regard to the performance to this set of key performance indicators. So we developed 9 performance indicators, 3 technical, 3 economic, and 3 so-called advanced indicators. I don't want to go into detail in all of them, but of course on the technical side we looked on the savings. We said we want to look on the primary energy savings expressed in tons of oil equivalent. And of course energy consumption improvement, so the reduction compared to the baseline energy consumption gives you an idea about the efficiency of the measure, and also energy intensity reduction. Economic indicators have been the simple payback time, but also the cumulative cash flow, which is the sum of costs and energy savings over the technical lifetime. We had the share of project costs subsidized. It's very important when you want to understand what is the motivation behind implementing an energy efficiency measure. And the so-called advanced indicators like the cost of energy savings, cost of carbon savings, and the share of renewable energy. Beside these key performance indicators, we also want to look on the number of occurrences of a measure, because if a measure is often implemented, in practice there is a reason for it. Maybe it has a high efficiency, it's easy to implement, or it has low investment costs. So this was also information we want to take into account. And to categorize the measures, we developed a taxonomy that allowed us to compare and categorize all measures. And we developed 2 types of taxonomy, one generic and one specific. And the generic taxonomy allows a comparison of all, is a generic approach and allows a comparison of measures across all different processes and sectors. And you can see here an example for the machinery sector. Based on the generic taxonomy, there have been 80 measures related to heat recovery, 71 related to biomass boilers, 61 to process design and optimization, and 56 to variable speed drives. And when you look on the distribution of the number of measures implemented and our connected energy savings, it shows the following picture. On the left side you have the numbers of records expressed by the orange balls, the generic taxonomy of the sector. And on the right side you have the final energy savings expressed by the green line. And when you look, for example, on the furnace, we have a very low number in really implemented measure, but a high energy saving potential. And also on the other hand, or on the contrary, when we look on biomass boilers or measures that are related with the installation, replacement of fossil-driven boiler to a biomass boiler or an optimization process, you have very low energy savings, but as I mentioned before, a lot of environmental benefits. So having all these different KPIs, at the end we still make a decision on whether efficiency measure is a possible good practice or not. And we did that by a point system to normalize all KPIs. So each KPI receives 0 to 10 points, depending on how well the measure performs compared to the other measures in the sector. The best measure, or the best KPI value of a measure, receives 10 points, the worst measure 0 points. All other measures are somewhere in between, and if there have been some data gaps, they are interpreted neutrally by 5 points. And the sum of points gives the final KPI score, and this gives a good idea of the best performance of the sector. You can see here an example of that. You have the green columns, which are the KPIs for a lot of measures in the machinery sector, and the values are normalized by a point system. So each value in comparison to all other values in the sector gets a specific points or scoring, and at the end we sum it up. And when you look on the distribution curve of all KPI scores in the machinery sector, you get a good idea or understanding where are the best performers of a sector. So somewhere here you could say, so this is because, as I mentioned before, maybe biomass boiler have a bad score when it comes to energy efficiency KPIs, but a high score when it comes to environmental benefits. And as you remember, we have 3 steps in our methodology. So this was the key, the quantitative analysis was more or less the key of our methodology, but it was backed up also by best available technology literature research. So we looked at the graph documents, we looked on other literature and tried to find links between it. And of course, at the end, we had the energy engineering evaluation, especially for the innovative aspect of a measure, because innovation is very difficult to express innovation by a KPI or a number. So for that, you really need the assessment of an expert. So this selected list of good practices have been qualitatively assessed by experts. For specific questions, we also contacted external experts and had a discussion with them, and of course also a lot of discussion within the project team. And all together, at the end, all together led to the decision if a good practice, if an energy efficiency measure is a good practice or not. And all good practices are available on our project platform. So that's it for the methodology of choosing, or the presentation of the information available, and the methodology of choosing the good practices. If you have questions.